For problem 1.6 of problem set 1, we have a system defined as y of n equals 3 times x of n squared. We first want to determine whether a system is linear, and so we have two tests to see whether the system is linear, whether it scales and whether it's additive. So to see whether it scales, we define an input f of n is equal to a times x of n, which is just a scaled version of x of n, and we want to see whether the output it would be a times y of n, basically a scaled version of the output of the system here. So we first solve for a times y of n, which is 3 times a times x of n squared, and then we find the output for f of n into the system, and we find that g of n, which is again the output of f of n, is equal to 3 times f of n squared, which is basically the same relationship between y of n and x of n here. You see the same pattern is between g of n and f of n here. Then we solve, and then we substitute back in for f of n in terms of this relationship here, and we get 3 times a times x of n squared. We see that these equations are equal, so it passes scaling. Next test is additivity. Basically, you define three equations. y1 of n is equal to 3 times x1 of n squared, y2 of n is equal to 3 times x2 of n squared, and g of n is equal to 3 times f of n squared. Then you define f of n is equal to x1 of n plus x2 of n, and you see, okay, if this is the input, is the output the sum of the two former outputs, basically? So the output for x of 1 of n is y1 of n, the output for x2 of n is y2 of n, as we showed here. If the input is the sum of these, is the output the sum of these? So basically, we find y1 of n plus y2 of n. We find that it's equal to 3 times x1 of n squared plus 3 times x2 of n squared. And then we find g of n, and we find that it's 3 times f of n squared, the same property again between y of n and x of n as we saw. And we find that that would be equal to 3 times x1 of n squared plus x2 of n squared. And so if this distributes, then it's the same exact equation as up here. So basically, this passes additivity, so it's linear. Then we want to test whether it's time invariant. We define g of n is equal to 3 times f of n squared. If f of n is equal to x of n minus n naught, is g of n equal to y minus y of n minus n naught. So basically, you first solve for y of n minus n naught. You get that it's equal to 3 times x of n minus n naught squared, where n and minus n naught is in parentheses. And then you solve for g of n, which is 3 times x of n squared minus n naught. You see that these aren't equal, and therefore it's not time invariant.